947 million light-years away, scientists observed something extraordinary. A spiral galaxy, remarkably similar to our own, is releasing two powerful jets of energy, each stretching across 6 million light-years. At the center of this eruption is a supermassive black hole, no longer quiet but active and accelerating matter at near-light speed. The galaxy is named J2345049, and its structure closely resembles our Milky Way. But what's happening inside it offers a rare window into something we've never seen before: a spiral galaxy with a black hole behaving like it's in the early universe. This raises an important question. What would happen if the black hole at the center of our Milky Way, Sagittarius A star, suddenly became active in the same way? In this video, we explore the latest research behind this discovery and how it could reshape our understanding of black hole activity in galaxies like ours. Because when scientists looked into this galaxy, they weren't just observing another distant object. They were, in a way, looking into a possible future for our own galaxy. In 2023, astronomers studying the distant universe stumbled upon something rare. This galaxy, located nearly 1 billion light-years away, appeared at first glance to be just another spiral galaxy. Structurally, it looked almost identical to our Milky Way: flat, rotating arms, a calm disk, and a dense central bulge. But deeper radio observations told a very different story. Unlike most spiral galaxies, which tend to host quiet or dormant black holes, this galaxy was doing something unexpected. From its center, astronomers detected two colossal jets, beams of matter and energy extending over 6 million light-years. That's 60 times larger than the galaxy itself, and they weren't just passive signals. They were high-energy relativistic jets launched by a supermassive black hole in full activity. This discovery was striking because typically only elliptical galaxies, those formed through violent mergers, show this kind of aggressive black hole behavior. In spiral galaxies like our own Milky Way, the central black holes are usually quiet, feeding slowly on the surrounding gas and dust. This galaxy broke that pattern. Its black hole wasn't just active, it was operating on the same scale as black holes in the early universe, when galaxies were more chaotic and unstable. Scientists realized they were looking at one of the only known spiral galaxies exhibiting such extreme jet activity. And here's where the question shifted. If this kind of eruption is possible in a spiral galaxy, then what's stopping it from happening here, in the Milky Way? Because at the heart of our galaxy sits Sagittarius A, a supermassive black hole estimated to be 4 million times the mass of our Sun. Today, it's quiet, dormant, observed mainly through its gentle gravitational pull and occasional flickers of X-ray light. But what if that changes? What if, like in this galaxy, something triggers a new phase of activity? Could it launch similar jets? Could it affect star formation, planetary systems, even Earth? The discovery in this distant galaxy didn't just challenge theories of galactic evolution, it raised real observational questions about the future of our own galaxy. Questions scientists are now actively modeling. In the next chapter, we'll look at how these jets form, why they matter, and what current simulations say about what would actually happen if Sagittarius A became active again. At the core of almost every large galaxy in the universe lies a supermassive black hole. But not all of them are active. In most spiral galaxies, including our own, these giants remain quiet, consuming material slowly and releasing minimal energy. They're not entirely dormant, but their behavior is stable. They don't disrupt the galaxy around them. But when a black hole becomes active, truly active, the consequences ripple far beyond its immediate surroundings. The black hole in this galaxy isn't just consuming material, it's creating order from chaos by funneling matter into powerful, narrow jets. These relativistic jets, launched at nearly the speed of light, shoot out from the galaxy's center along its poles and extend for millions of light-years into intergalactic space. But how does that happen? It begins with accretion, the process of a black hole pulling in surrounding gas and dust. As this material spirals inward, it forms a glowing superheated accretion disk. Magnetic fields within this disk twist and tangle until they become powerful enough to launch some of that infalling material outward instead of inward. The result? Beams of ionized particles fired across the universe. A phenomenon so powerful it can suppress star formation across entire galaxies. This isn't theory, we see it in active galactic nuclei, or AGN, and in the violent jets of quasars and radio galaxies. These jets can heat up vast clouds of gas, preventing them from collapsing into stars. They can alter a galaxy's shape. In extreme cases, they can even push material out of the galaxy entirely. So what makes this galaxy different? And so important because it breaks the mold. This is a spiral galaxy, not an elliptical one. Spirals typically don't have the kind of chaotic, merger-driven environment that activates such intense black hole behavior, which means something else must be going on, something scientists still don't fully understand. And that brings us back to the Milky Way. Our galaxy hasn't had any large-scale mergers in billions of years. It's relatively calm, but Sagittarius A, while quiet now, has shown signs of activity in the past. Fermi telescope data even suggests there may have been small jets or outbursts millions of years ago, long enough that they didn't affect us, but recent enough to remind us that black holes are not permanent fixtures. They evolve. The real question now is, under the right conditions, could ours erupt again? What would that look like? What would it mean for Earth, the solar system, and our position in this galaxy? In the next part, we'll examine the chain reaction, how a renewed outburst from Sagittarius A star would spread through the Milky Way, what it would hit, and how close we are to truly understanding the risks. So let's take the scenario seriously. If the black hole at the center of our galaxy, Sagittarius A, suddenly reawakened with the same intensity as this galaxy, what would actually happen? The first thing to understand is scale. The jets in this galaxy span 6 million light-years. That's not just impressive, it's terrifying. If Sagittarius A star produced anything close to that, the effects would echo through the galaxy, but not instantly. These jets don't travel faster than light. Even at nearly light speed, it would take thousands of years for their full reach to affect regions like the solar system. And because the jets are directional, Earth would only be directly affected if one of them was pointed in our direction. That said, there are indirect consequences. As jets erupt from the black hole, they interact with the interstellar medium, the gas, dust, and magnetic fields that fill the galaxy. These interactions can create massive shockwaves. They can strip gas from star-forming regions, shut down future star births, or trigger new ones in other locations. It's a process that can reshape the galactic ecosystem. In the Milky Way, we're about 26,000 light-years from Sagittarius A. At that distance, Earth wouldn't be in the direct line of fire, but it wouldn't be unaffected. One of the biggest risks is gamma radiation. When black holes become active, they emit bursts of high-energy particles, gamma rays, X-rays, and cosmic rays. These could penetrate our atmosphere, disrupt satellites, damage the ozone layer, or even increase mutation rates in living organisms over long periods. Then there's the Fermi bubbles, massive structures already detected above and below the Milky Way's core. These are remnants of past black hole activity, still glowing with residual energy. If Sagittarius A erupted again, similar structures could form, expanding slowly through the galactic halo. and changing how our galaxy looks for millions of years. Yet despite all these risks, there's an important truth. There's no sign that Sagittarius A is preparing to erupt on that scale. It's quiet, monitored, stable for now, but the discovery in this galaxy J234504449 is a reminder. Galaxies can change, assumptions can break, and in the vast timeline of the cosmos, what seems dormant today can erupt tomorrow. The real takeaway isn't fear, it's perspective. Our galaxy isn't immune to the extremes of cosmic evolution, and as we learn more about distant galaxies behaving in ways we never expected, we also learn more about the forces shaping our own, past, present, and future.